This video covers chapters 9 and 10, or at least parts of chapters 9 and 10, on no arbitrage restrictions on option prices. In other words, I'm looking at boundary conditions, and I'll start off with the boundary condition for call options. First, the minimum value of a call, is going to be 0. And the way we denote that is the call, it's going to be greater than or equal to 0. So the minimum value of call cannot be less than 0. Why? Because a call is a right, not an obligation to buy a stock. And what I mean by a right is you're not forced to exercise the option if it's out of the money and it goes against you, and it'll actually detract from your value. So given you have this right, you don't have to exercise it. The call that, as a holder, it'll never be less than 0. And when the option finishes out of the money, it'll finish at 0 with the little equal sign there. Now, I write this, for this applies to both American and European calls. Now remember, an American call option, or just any American option, you're allowed to exercise, you have the ability to exercise it before expiration, anytime before. And a European, you're only allowed to exercise at expiration. Now, for an American option, let's look at an American option. An American option, like I said, can be exercised at any point in time. So the minimum value of an American option is going to be, taking into consideration this 0 when it's out of the money, and then you have to consider the fact that it could be in the money, and when it's in the money, the payoff from the option is going to be S minus K. So at any point in time for an American option that does not pay dividends at this point, we haven't considered dividends, it's going to be the maximum of 0, and it's going to be 0 when it's at or in the money, or at or out of the money, and then if it's in the money, the option is going to be worth the difference. Because if you were to exercise this option immediately, what would you get in terms of payoff? You'd get this amount right here. Okay, that amount right here is often called the option's intrinsic value. How much is the option worth if you could exercise it immediately? Okay, let's look at the lower bounds to a European option. And a couple of details. I mean, the American option is somewhat simpler, but with European options, it's a little slightly more complicated math. I mean, hardly any more complicated math. But what we have to consider with a European is that we're looking at a European option right now. We're not going to be paying K. We have no ability to pay the strike until expiration. So we have to consider the present value of the strike. So I have to consider the present value of K. And the present value of K is simply K to the E power minus R times T. And so we're discounting at the risk-free rate over period T. It's discounting because there's a negative sign there. And we're just computing the present value of that K. And so when we do that, you basically have, for a non-dividend paying European call option, non-dividend paying stock underneath, it's the maximum of 0, or S minus PVK. And you don't be thrown off by this type of written language here. Like I said, this written language, it considers the fact that the minimum call option, the minimum value of the call, is greater than or equal to 0. We can easily write this as the call must be greater than or equal to S minus PVK, present value of the strike. And that's the way it's written in the textbook. And this formula assumes that you realize the value of the call cannot be less than 0. Okay, so that's one other thing. And now, in the same thought now, when you have an option and you're looking at time t, and the option expires at time 0, and you're looking at an expiration at time t, a stock may pay a dividend between now and the expiration of the option, in which case we need to consider the present value of the dividend today. Because we're not getting the dividend. If we're sitting right here, we don't have possession of the dividend yet, and we're going to have to compute what is it worth today. And the present value of the dividend, in a similar fashion, is simply the dividend continuously compounded, discounted back at rate R over time period t, where R is the risk-free rate. So, a European call option can look like this in terms of a formula. It could be the maximum of 0, or the stock price minus the present value of K minus the present value of dividends. You might want to ask, well, why did I subtract out dividends? Is because the stock price will be reduced during the life of the option. During this life of the option, when the stock pays a dividend right here at this point, the stock is going to drop by the amount of D. So we need to compute the present value and subtract it from today's stock price, because we're looking at today's stock price here. It's going to drop at this point. And if you put everything in today's dollars, it's the stock minus this present value adjustment. And in terms of a formula that matches the textbook, it's stock minus present value K minus the present value of dividends. Now this is an important relationship, and so we're going to derive this lower bounds using a no arbitrage situation. So that's why this is called no arbitrage restriction. So we could build a table like we've done with futures contracts and actually show this concept. Okay. So what I'm going to do is I'm going to build a table. Okay. Going to build a table. And I'm going to label here current value of the portfolio of some assets. And I'm going to look at payoffs at expiration. And I'm going to look at when the stock price at expiration is less than or equal to K, it's out of the money, and when it's greater than K, the stock price is greater, when it's in the money. And we're going to look at two portfolios. Okay, portfolio A is a stock. We're going to own a stock, and that stock is worth S subscript 0 today. Okay, and we're going to compare that to a portfolio B, which is made up of a call option, a European call, plus a bond. Okay, and the value of this portfolio is CE for the call plus the value of the bond. And the value of the bond that we're going to do is we're going to compute the present value of the strike. That can be considered a bond, because think about it conceptually. This you could think of entering into an option as, you know, if this option goes in the money, I'm going to exercise it and pay K. So why don't so if you want to build a no arbitrage situation, you want to consider the present value of K, and think of that as a bond that pays off at K. So it's worth this much today, and when it matures, it'll mature for K. Okay. Now, let's look at what happens with these payoffs at expiration. The stock price will be worth ST. It doesn't matter if the stock is above or below the strike. Whatever it ends up, it'll be S capital T. Okay. Now, for the call will be worthless when the stock is below the strike. So the call will be worthless. But what you'll end up with is K. Okay, so you buy the bond here. What's it worth at expiration? It's worth K. You can ignore the 0, but I put it there just to be complete. Now, when the stock is in the money, the call is going to be worth ST minus K plus that bond. That bond happens no matter what. You see that bond here? It's going to pay off K no matter what, because the bond matures for K. Now, this whole term, right, ends up to be ST, because the K's cancel. Now we ask ourselves, which portfolio is more valuable? And we do that by focusing and comparing these two rows. Oops, I should include that guy there. These two rows, and look at it on a case-by-case situation. One case being below the strike, above the strike. And if we compare, we find out that here, what we find out is that if the stock price is less than K, then the winner here, the better portfolio in this case, is portfolio B. This is the better portfolio because K will be larger than ST. And if you're looking at when the option finishes in the money, then they're tie. ST is equal to ST. So what we have is, we can write a relationship now for this. The call option plus the present value of the strike, in other words this, must be greater than or equal to the stock price today. And you can put a little subscript here just to be consistent, or as many textbooks and many other versions of this you'll find on the web and in other research and articles, they'll just leave out the subscript 0, which is very common. So what I've done is we've shown the lower bound on the option. And how do you know that? Well, we just rearrange. We'll bring this over, subtract PVK from both sides. And we come up with CE greater than or equal to the stock price minus the present value of K. I dropped the little subscript 0. Okay. Now, don't forget, if the stock happens to pay a dividend, and this, I've assumed the stock didn't pay a dividend, for simplicity in the derivation, otherwise it gets a little messy, you can see that we can just take the stock minus the present value of K minus the present value of the dividend. So the call option must be greater than this. Value of the call, European call, must be greater than this. Now, let's look at a maximum value of a call. The maximum value of a call, since a call, the only thing you can do with an option is convert it into the stock if it's in the money. A call can't be worth any more than the stock. And that says a maximum. So the call has to be no greater than the stock price. So normally the call, in other words, the call will be less than the stock price almost always. And that's quite interesting. It imposes an upper bound on the call option. And that upper bound can happen when K equals 0 or T, I think I have and in the notes, it's K equals 0 or T goes to infinity. And I'll explain this in 1 minute when I draw the graph. And we'll see how this works, how you can think about. Okay, so now I am about to draw the graph of what I've just done in the past 2 pages, and it'll very much help you visualize what I've been talking about. I'm big on visualization, not just the math, but the visualization part too. And so what we have here is basically the hockey stick, in a sense, for a call option, and that when it's call option's out of the money, it's 0, right? And when it's in the money, it pays off 1 for 1. This value of the stock pays off. This is the intrinsic value of the option. So with an American option, this line is the maximum of 0 or S minus K. Okay, this being the intrinsic value right here, and 0 being along this axis. Now, with a European option, here we have a European option, and the European right, is the maximum of 0, or S minus the present value of K. Close that bracket there. Okay, so what you see here is this difference. Some authors will call this the intrinsic value of the option, even though you can't exercise it immediately and get this intrinsic value. They'll still call it the intrinsic value. But the intrinsic value, this number here, is greater than this number, and it's greater by the difference between the K and minus the present value of K. That's this difference here. Okay. Now, that's the lower bounds. These are the lower bounds for an American, a lower bound for European, and the upper bound, regardless of what type of, whether it's an American or a European, this is the upper bound. And the upper bound is basically boils down to the call option equals the stock, or I should say, the call option should be less than or equal to the stock, but in this case, this line is equal to call equals the stock price. And that happens, as I said a few minutes ago, when t goes to infinity or k equals 0. Now, how does that work now? How can you get that? How can I say that? Well, go right over to the math here. What happens? Let's look at the American option. What happens if I plug in a k of 0 for the American? I say it's the maximum of 0 or S, right? It's the maximum of 0 or S, which means the call is going to be greater than or equal to 0 or S. Here's where it's 0, and here's when it equals S. So you're right here on this line. It's as though, think about it, you're dropping this k to 0. So you're bringing this whole line right over when you drive this to 0. Okay? And with the European option, remember it's the maximum of 0 or S minus present value of k, right? Well, again, drop 0 in here, and the present value of 0 is 0, and without discounting it all boils down to 0. So again, it's the same thing as sliding this whole line over. Okay, so there I just accounted for k equals 0 right here. I've accounted for the k equals 0. But what happens if t goes to infinity? How does that relate to this upper bound? Well, look what happens. If you were to think of this, go to the European. I think the best way to look at this is go to the European. If you have an infinite amount of time before you exercise the option and can pay k, what is the present value of something of k that you're going to get in the infinite future? It's going to be 0. So basically this European line will again slide over if you think of t going to infinity. And as we'll see in a few minutes, a American option has to be worth as much as a European option. So we'll see in a minute that this line actually is misleading us, that really the boundary condition is here for American option. So this is an illusion. The real boundary condition is a little tighter as it moves up here, because an American is going to be worth at least that of a European option. Why? I'll tell you right now, and you think you already know it, is because with an American option, you have extra optionality that a European just doesn't give you, and that's the ability to exercise at any point. So an American can do everything a European can do, plus more. Okay. Now let's look at time to expiration. How does that affect us? Well, we already saw a little bit of that a second ago when I said t goes to infinity, how it drives how it can drive the option right up to the point where the call equals the stock price. And so what you need to know here is, how does the time of expiration affect option prices? And when time goes up and you increase the expiration, in other words, longer term options, it means the value of a call is going to go up. And you can think about it, as I often say in class, options are very much like insurance contracts, where you have an insurance company writing insurance, and you buy that insurance, and you have the option to exercise it if your house burns down or you get into a car accident or become disabled. So what you'll find is that if you have a 1-year insurance is worth a lot more than 6 months worth of insurance. So you can see that the longer the time you have, then the more valuable the call is. And it's also, for the most part, true with put contracts too, as we'll see later on. But there's issues that we have to talk about, so we don't want to make blanket statements yet in this area. Okay, now one more thing here with respect to the graph that I did not show you. Basically, you're gonna see this graph time and time again in class. You're almost never going to see, after this chapter, you're almost never going to see the upper bound. Nobody ever draws the upper bound. It's always this lower bound that we are always up against. And this is the lower bound, the value of the option at maturity, which is why I always said, at maturity, I kept using the S little subscript T to denote this. And with an American, it's just the intrinsic value right here. But an option during its life looks something like this. During its life. In other words, this option has a lot of value. The longer the maturity, the greater the value of the option, because the option why is that? The option has the ability, the stock is gyrating back and forth between above K, below K possibly. The more volatile the stock and the more time it has to gyrate back and forth, up and down, means it has a chance of going very deep in the money. And so when it does that, it has this value, the over and above intrinsic value, and that's for the opportunity that the holder may get if the option finishes deep in the money. And so you get that value. Here, the option becomes worth less and less because the probability of the stock finishing in the money above K is very slim, so it's not worth very much. And the option is worth a whole lot up here because it can finish in the money. And so here we also know that here's a big ST minus K intrinsic value. And what we'll talk about later in the course is, why is this so small? Why is the extra premium that you're paying over and above the intrinsic value small when, say, for example, right at this point, look at the size of that gap here. 0 intrinsic value, but you have a large amount of premium. And we'll talk about that later in the course, especially when we talk about the Greeks in a later chapter. Now, so keep in mind, so that when you have an option that matures, that has a much longer maturity, the option will be much further out. Okay, much further out. And an option that is ready to mature, this whole line, these lines will start to collapse in. So they'll start to collapse in, and you'll start to notice some kinking going on to the point where it'll melt right in to this at expiration. At expiration, you got to be on this line. So you see these curves coming in, melting in, so it ends up having a kink at expiration. Okay. Now, the question becomes, should we ever exercise an American option early? And let's start out with a non-dividend paying stock. So, should we exercise it early? And the answer is no on a non-dividend paying stock. Let's explore why that is. And we have to go into decomposing call options, the premiums in the pieces. And we decompose it into pieces, we'll see why it's never optimal to exercise a call option early on a non-dividend paying stock. And with a dividend paying stock, we'll find that, most of the time, you shouldn't be exercising the option, but there are occasions exercising early. There are occasions when you might want to exercise an American call option early. We'll talk about that. That's where we're going now. So now what I want to do is decompose option prices into three components. Call premium, the value of the option, equals its intrinsic value, right? Intrinsic value, which for a European, that intrinsic value is the stock minus the present value of K. So think of that intrinsic value. Even though you don't have access to this with a European option, like I said before, because you can't exercise the option, if you could, the value of this option intrinsically at this point is worth this difference, even though you can't get your hands on it yet. Plus, there's a time value component. Plus, there's an insurance value. Okay. The time value component, okay, is I'm going to have to do a little bit of math tricks to break out and tease out what these components equal. And the way to do that is simple. I'm going to add and subtract K from the right hand side. And so we're going to have the call is going to equal to K minus S. Now we're looking at an American basically, right? Plus K minus the present value of K plus the insurance value. Okay. So here's the intrinsic for an American. Here's the difference between here. This was basically this time value. Time value, I had it right here. It's the difference between the European and the American values, the difference between those two lines. And so this collapses to zero when at expiration. There's no time value left. This will collapse because the present value of K will equal K. K minus K is 0, okay, at that point. And then at expiration, there's no insurance value left either because there's no chance for the stock price to change at expiration. You're locked into whatever the stock price matures at maturity for the option. So this is 0. So at maturity, you're left with S minus K. So these three components are important to explaining option values and why it's important to stay away from exercising an American calls early. So when you exercise an American call early, you grab this. You're getting this intrinsic value, but you're throwing away this difference and you're throwing away the insurance value out the door so you can get your hands on this. And that just doesn't make sense. If you want out of the option, it's optimal to sell the option. If you sell the option, you will get this in value, the intrinsic value, from the person who buys it. You'll get this from the person who buys it, and you'll get this component because you're going to sell it for C. Now, keep in mind that many authors, textbooks, the websites, research articles, they will often consider this whole thing, they'll often consider this time value. So just be careful if you go to other literature, other textbooks, websites, books on the subject, research, they'll often consider this combined. This is, your authors are one of the few authors that will break it down into pieces, but it's extremely insightful, and I don't know why other authors don't do it, but I think it's extremely insightful. Now, why is an option worth, why is a call option worth this? What is this conceptually? Well, this adds value to the call. See, it's positive. It's adding value to the call. Because an option allows you to defer the purchase of the stock until expiration. It allows you to hold on to K. You're allowed to hold on to your money until expiration. How much is it worth to hold on to your money till expiration? This difference. The difference between K and the present value of K is the amount of value that you get from a call option from deferring purchase. Now, let's look at let's think about this now. Let's do an example, as I have in my notes, and I'm on page 5 of my notes. So we have a stock that trades at 25. It's a 6-month call, so T is 1/2 a year. The strike is 23. The R is 3%. And the call is trading at 5. So now, what are the components of this option? So C equals S minus K plus K minus PVK plus insurance value. It's worth doing this exercise so you see what you're going to see is, we can observe this in the Chicago Board of Options Exchange, Wall Street Journal, CNBC. We can observe the stock price. K is on the option quote. We can compute the present value of K because we know what the risk-free rate is. It's in every financial website out there. And then what we find out is the only thing that's missing is the insurance value, and we have to back into it. And then we have all our components. So this guy is equal to $5 as given. This is 25 minus 23. If we had the ability to exercise this option now, we'd gain $2. We'd be throwing this away. This component is 23 minus 23e to the minus 3 times 1/2. Oops, I should be careful. It's e to the minus 0.03 times 1/2. A little sloppy there. Plus the insurance value. Okay. Now, this component right here is worth 34 cents. This component has to be worth 266. This is 2. So 266 plus 34 cents plus $2 adds up to the 5. So we have 35% value from this call option from the fact that we can delay exercising the option until expiration and not paying the 23 until expiration. And given the interest rates of 3%, it's half a year, it turns out to be 33 cents. We're paying $2.66 for the hope that this stock finishes even deeper in the money. Right now it's in the money by $2. You can see that right here. But this stock price could easily go to $30, $35. And that's what you're paying for down here with this insurance value. You're paying the $2.66 for that ability to do that. Now, if you have dividends, then you break down this component, the components, into the same 3 components, but you're going to also have to subtract out the present value of dividends in there. Okay, so when you have dividend paying stock. So then the question becomes, when should I exercise the option early, an American call option early? on a dividend paying stock, because it might be optimal to do that. Well, as I said earlier, if you exercise the option, you throw this away. It gets thrown away. But what happens is, if you exercise the option, you actually capture this dividend. So the question becomes is this amount I circled greater than the dividend? And if this amount is greater than the dividend, then you don't want to exercise. You want to hold it. You want to actually sell the option, and it's to your benefit. But if this present value of the dividend happens to be worth more than this intrinsic, or this insurance plus time value, then you should exercise the option right before the ex-dividend date, so that you can exercise the option, get the stock, and have the stock pay this dividend, because you'll get this in your hand, and you'll be throwing this away from exercising the option, but you'll get this in your hand. If this is bigger than this, you're better off. So the only time you want to exercise an option is when the call option early is when that dividend is bigger than these in time value and insurance value. And when is that most likely to be? Well, if this is small, which is usually to where it is right now, because interest rates are low. So when interest rates are low, this time value is going to be small. And if the volatility of the option is very low, then the insurance value is going to be low. So when interest rates are low, volatility is low, and you have a high dividend paying stock, you probably want to exercise it. And when? Right before it goes ex-dividend, so that you get the stock from exercising, and then you're entitled to the dividend at that point. Okay. Just a brief discussion on interest rates. We've already covered interest rates. We know that it affects, it comes through time values, just one way it comes through, K minus PVK, as a component to option prices. And so it affects this time value. It affects the time value. Whoa, so you can see it. It affects the present value of dividends also, if the stock pays a dividend. But out of all the variables that affect option prices, and the inputs are S, K, R, sigma, stock price to strike price, the interest rate, the volatility of the option, and time to expiration are the main inputs. And then if you have a dividend paying stock, it's D. But out of all these variables, option prices are the least affected by changes in interest rates. But it does have an effect. It is in there. It's included in these values, in these formulas. But you have to change interest rates a whole lot in order to influence option prices a lot. Okay. What is the most influential variable? I mean, obviously the stock is the most influential variable out there. If we assume K is fixed, which it kind of is over life, the thing that really influences an option is sigma. Sigma really influences the option. It's the volatility. And as I said before, you got the stock price, you got K, and you got the call. And so if this option is whipping back and forth, back and forth, back and forth, then you have an option that's worth more, because there's the possibility that it goes deep into the money and it's going to be worth a whole lot of money. If it drops, the stock drops all the way down, the most you can lose is zero. So you're not going any more negative. You're not really going negative. You're just dropping down to here. The most you can lose is the value of the call that you had paid initially to get into the option. Now, what we'll do next is we'll talk about put prices. We'll talk about the minimum value of puts and the maximum value of puts. Now, let's consider put option bounds. Now, the minimum boundary for a put is the put value has to be greater than or equal to 0 because of the optionality thing that we had, just like with a call option. Since you have the right to exercise but you're not obligated, this option has to be greater than or equal to 0. Now also think about an American put. An American put can be exercised immediately, and so the American put is going to be greater than or equal to K minus S. And if you consider both of these combined, it's the maximum. Oops. So the lower bound on an American put is the maximum of 0 or K minus S for a non-dividend paying stock. Okay. Now with the Europe, let's look at maximums now. Let's look at the maximum value of a put for a moment. The maximum value of a put is the put has to be less than or equal to the strike K. Because remember, why is this the case? Because the only thing you can do with a put option is convert it into cash. Because you're going to sell a stock, and what are you going to get from that? You're going to get K. So the put can't be worth any more than K in terms of cash. And if the stock becomes worthless, you're going to sell a stock for K that's worthless. The maximum value is going to be K. Now with a European option, the maximum value is going to be the present value of K, because when you hold a European option, you can't actually get your hands on the proceeds today. You can only get them at expiration. So you have to compute the present value of that cash flow today. So if we did a quick example in calculating put and call boundary conditions, upper boundary conditions, suppose we have an American put and a European put, each with a strike of K equals 50, and the risk-free rate is 4%, and the company just went bankrupt, so S equals 0, and the maturity is 6 months. Okay, compute the upper bounds for each put. Well, for the American, it's going to be $50 because it's going to be K minus S, which is 50 minus 0 is $50. For the European option, it's going to be the present value of K minus S, which equals the present value of K is 50 e to the minus 0.04 times 1/2 minus 0 gives me about $49 is the upper bound for that European option. Okay, when a put matures, keep going here. Now when a put matures, the put equals a maximum of 0 or K minus S. So at expiration, this is what holds. And we've looked at this a whole bunch of times. That was the foundation for the hockey sticks. Okay. So let's graph. Let's actually graph the boundary for an American option at this point, because we're ready for it. Put some space here so we have a put. And what we have here is the maximum value of a put is K. For an American put, so put American. This is K on this axis. And what we have is, here's the hockey stick at expiration. And here's the rest of the hockey stick. So at expiration, here's that K minus S. And the most you can get is if the stock drops to 0, you're going to get K. And so with an put option, you can exercise at any time. So if the stock immediately drops to K or to 0, you're going to get K in proceeds. And the value is worth anything along here. If it's in the money, and if it's out of the money, it's along here. So that's the boundary. And basically what it's saying is the option value can fall anywhere in here for an American put. Keep in mind that American puts, and for any put, the actual put at any time other than expiration will look something like this, and it'll you'll see this maximum around K, ballpark around K, for this being the insurance and time value, which we'll get to shortly in our analysis. And you'll see asymptotically it moves up to the hockey stick on both sides here. And again, that comes out the discussion of the shape and why we see thin lines, a thin space between here, thin space here, and a wide space here. It comes out in the Greeks in the later chapter as to why that is. Okay, now we're in a position to decompose put values into the three components, just like we did with call options. We have intrinsic, time value, and insurance value. And so let's start out here. So put value equals intrinsic value plus time value plus insurance value. And keep in mind, many other textbooks and sources will combine these and just call it plain time value, these two components. But your authors break it out. They break it out for calls. They break it out for puts. Also, it's very convenient. Now add and subtract both sides, K to the right-hand side. So you have a put value equals now K minus S. Okay. Minus K minus PV of K plus an insurance value. Okay. Now, let's see what's going on here. Well, basically what I did was, and I may have sort of skipped a step. I'll see if I put it in on green here. We basically start out with an option. I'll cover this up. We basically start out with the PVK minus S. If we think of it from a European option perspective, it's the present value of the K minus the stock price, right? Plus in some insurance value. And so we add and subtract K to this. We end up breaking it out, and it kind of looks like an American option at this point, because here is the American payoff, K minus S. Here, and I should put brackets around this whole thing. Here is the time value component. But notice this for 1 second, that you have a minus sign, and we'll talk about that in a second. Then you have the insurance value. So look, you have a time value component, just like you do with call options. So it's the difference, it's really time value of money between K and the present value of K. Now, it's negative here, which is different than a call, because with a put, it gives you, the put represents the ability to exercise an option later on. For example, exercise this, to sell this, I should be careful, to sell this stock later on. And so a put gives you the ability to delay sale. That's negative, because that's what it's telling you, is it's a delay of cash proceeds. And so by holding a put, you're delaying the sale, because you're not exercising it. If you're holding the put, you're delaying the sale, in which case that's a detractor, because you're not getting your proceeds now, and you're losing opportunity cost of money, which is right here. So that's a minus sign. So now, when you think about considering exercising a put option early, you got to ask yourself, okay, so when I on a non-dividend paying stock, the answer is not quite as easy with a call. It may sometimes be better to exercise an American put early, because when you exercise an American put, you're going to get this amount, but what you're doing is you're giving up these two components. you're giving up this negative, which is good, but you're throwing away the insurance value, which is bad. And so when you look at an American option, put option that does not pay a dividend, you have to decide whether or not which is bigger before you exercise. And if it turns out the insurance value is bigger than the absolute value of this component, then you should not be exercising early. You should be delaying. If it turns out this is bigger than the insurance value, exercise early, capture that time value of money, and you'll be better off than holding the option. So it's slightly more complicated with put options, and it has to do with the time value of money. Now, let's do an example. XYZ company trades at $40. Okay, S is at 40. Puts with a 6-month expiration and a strike of 43, trade for $7. Risk-free rate is 4%. And it's asking us, and I'm asking you, to compute the opportunity cost of exercising the put today. What's the cost of the opportunity cost of exercising the put? So the put equals K minus S minus K minus PV of K, present value of K, plus the insurance value. Okay, that all equals 7. So it's 43 minus 40 minus 43 minus 43E, 4 times 1/2, plus insurance value. Notice I'm not given an insurance value. You always have to compute and back into that number. Just like with call options, we're given everything but this guy. So you could back into that, and if we did back into it, this would be $4.85. Because this is equal to 3, this is minus 85 cents, and so this has to be, the insurance value has to be $4.85. So the opportunity cost of exercising this option early, if you exercise this option early, you'd be gaining this, but you'd be throwing $4.85 away. So should you exercise this option early? No. You would not exercise this early. You're throwing 80. You're really all sum net. You're throwing away $4 in value if you exercise this option early. Just sell it, collect the $7, and be happy. Okay, let's look at the lower bound on a European put. Okay, the lower bound graphically. Let's visualize it here. Okay. Present value of K. Okay, so this is European put. And we have present value of K here, so we'd have K up here, put value. So here is the boundary condition for puts. So European put would have to trade in this area. Can't be in this area, can't be in this area, it's got to be in this area, and most often it has a value that looks something like that. And the longer the maturity, the further it's out and up there. And then as it matures, it collapses down, just like with a call. It'll collapse down, and it'll end up with a kink in itself at that point. Okay. So if you wanted to superimpose, let me see if I can get another color here for you. Superimpose purple. The American boundary, just as for comparison's sake, I'll put this thick purple marker here. Here's the American boundary space. It is a little different. So what you see is the American is always worth more than a European. The purple's American. And why? Because you get your money early. this difference represents time value of money. It's basically this 85 cents in this case. It's this guy right here is what's causing the drop in the value of Americans, where the purple is American and the black is European. Okay. So now we know we know that an American put can do everything that a European put can do, plus it has some benefits because you can exercise early. And so American put has to be greater than a European put. And then we said, like we said earlier, it also has to deal with time value of money concerns. Now, what happens when a put pays a dividend? When a put pays a dividend, for example, a European, then the put is greater than equal to present value of K minus the stock price, which is really the stock price today is a present value term, plus, and I have a typo in my notes on page 9, this needs to be a plus, the present value of dividends that we're going to receive during the life of the option. It's a plus because when a stock pays a dividend, the stock drops by the amount of the dividend, which means when a stock drops, the put is more valuable. So if you have a stock that pays a gigantic dividend, the value of the stock is going to drop. That put is going to be very valuable. People are going to want to hold that put, all else being equal. Okay. So now, let's summarize what we've just done. And I'm going to summarize the material. It shows up in two different places in your text. It shows up at the bottom of page 201 to the top of page 202 and at page 204. And then what I want to do is summarize what we found. Summary. And it'll be helpful. So, with call options, let's summarize the call options. We had upper bounds that said the call has to be less than or equal to the stock price. So the call couldn't be greater than the stock price. For an American, or for a European and for an American, the same thing. These are upper bounds. Can't be above this. It's a ceiling. Now, with euros, with European options, right? This is no surprise. The value of the European has to be greater than or equal to 0. That's a lower bound. And if you have dividends, don't forget, we said that the option has to be greater than the stock price minus the present value of the strike for a lower bound. And don't forget, if you have dividends, it's the present value of dividends get subtracted off. So here's the complete lower bound. Okay. Now, with an American, you have an American must be greater than or equal to 0 for a lower bound. No surprise. And an American must be greater than or equal to S minus K. There's no discounting with an American. And like I said in class, you know that you're dealing with an American option when you're looking at K by itself. And when you see a PVK, it almost always is telling you this is a European option. And K by itself, you got to be careful. K by itself sometimes can show up in a European, but it's usually around just an American. But when you, for sure, when you see PVK, that's a European. Okay, so that is a lower another lower bound here. Now, if we add in dividends, stock minus K minus the present value of yeah, we can do that. Present value of dividends. We subtract out because the dividends will be delayed. I mean, you're not going to be able to get your hands on a dividend if you own the call option right away. So it's the present value to dividends. And so since a call option, an American, is greater than or equal to a European, we can say CA greater than stock minus the present value of K minus the present value of dividends. And so the textbook combines all of these on page 202 and puts it into this form. Basically a triple bound. It says it's the maximum 0. If it's out of the money, it'll be 0. K minus S, or S minus K for an American. And then, since the American has to be greater than or equal to the European, we can write the third bound as being S minus present value of K minus the present value of dividends. Whew. So you get that triple bound. Okay, now let's summarize the put scenarios. So summarize put summary. Okay. We know that we have an American is going to be less than or equal to K. That's going to be the upper bound. Why? Because it's an option. The best you can do with an option is turn it in to K, cash proceeds. So the option, again, you have the right to do that, and so it's got to be it has to be no greater than K, what it can be turned into. And for a European, there's the time value of money concept right there, and there's the upper bound for a European. Now the lower bounds look like this. For a European, present value of K plus the present value of dividends minus the stock price. And this is for a European. Okay. Now for an American, it's K plus present value D minus S. And for a non-dividend, you just ignore the dividend here. Okay. Now, since the price of an American should be greater than or equal to the price of a European, then we end up with a triple bound. PA is greater than or equal to the maximum of 0 if it's out of the money, K minus S if it's an American, and then from a European perspective, we get this last term. And so that summarizes the boundary conditions. Now, if your head's not spinning, I don't know what will make it spin. This starts to get very monotonous, and there's a lot to it. As you can see, everything looks the same, and after a while, it becomes hard to, distinguish between puts and Americans and Europeans options, and then when you throw dividends in there, it's tough. So, as far as testing you on this material, I have to be very, very, very careful on how I go about doing it, because it's just, you're going to have a hard time with it, and even I would have a hard time. You've got to really stop, think, and analyze the situation before you draw the boundary conditions.